so now we spent like 3 minutes on this one, 5 minutes on this. Is everybody good and stuck? Feeling that way? Yes? So this is an example of, sometimes this happens halfway through a proof. You finally get both sides as a single fraction. One side is in sine, one side is in cos. And you're trying to prove it, but they're not the same. They appear to be not the same. So we're stuck. Now, in the strategies that we wrote down earlier, we put a star beside these red ones with an S for what to do when you're stuck. We've seen the factor strategy already, but this one, there's nothing to factor. So I'm going to introduce to you the build the other side strategy, which is also called multiply by the conjugate. Now, in the build the other side strategy, when things are not the same, you multiply them by 1 to make something the same. For example, we could make our denominators the same if we had a common denominator between the two of them. Does that make sense? So this one has a 1 plus cos theta. It doesn't have a sine theta. So I'm going to multiply the top and bottom by sine theta. This one has a sine theta, but it doesn't have a 1 plus cos theta. So if I wanted the denominator on this one to match the denominator on the other one, this side I need to multiply by 1 plus cos theta. And I call this building the other side because you're making something on both sides the same by adding stuff to it. So now would you agree that the denominator on this one, and I'm not even going to multiply it out, I'm just going to leave brackets around the 1 plus cos theta. In fact, it's sort of in factored form. That's my denominator on that side. My numerator will be sine times sine, which will be sine squared. On the left-hand side, I have the same denominator. And my numerator, when I multiply this out, 1 plus cos times 1 minus cos, it's a difference of squares, and I'm going to get 1 minus cos squared theta. So in the build the other side strategy, you're making something the same. Maybe you make the numerators the same, maybe you make the denominators the same. It doesn't really matter, because once you've made something the same, maybe there's a hint to make the other part the same. My denominators are now the same. Is there a way that I can change my numerators on one side or the other to make it match? So now you're just looking at the 1 minus cos squared. Can you change that to anything? Yeah, you can change that to sine squared. And then you look, and sure enough, we're done. Now on our strategy sheet, it had multiply by 1 and had the word conjugate in brackets. But my question is, from grade 10 and grade 11 math, do you remember what the conjugate is mathematically? Do you even remember hearing that word? So if you have, if you have x plus 3, the conjugate is x minus 3. Same thing with a different sign in the middle. Those two are conjugates of each other. It's such a weird definition that you never use that it doesn't even take a moment of your memory. And it might have been explained to you in grade 10 in one sentence once and then never used again, so you don't remember it. And so when I was first teaching this and saying, oh, the strategy is multiplied by the conjugate, that's like saying to people, let's multiply. Because if the words aren't things you use often, you're going to forget the word. And then if you forget the words, you end up forgetting the strategy. And then you end up just coming to this question going, I don't know what to do. So I renamed it Build the Other Side because it makes sense to make something the same. If you're stuck and nothing's the same, well, let's make something the same. And we can multiply by 1. Here's the sine over sine. Would you agree that's equal to 1? And we can multiply by 1 on this side, 1 plus cos and 1 plus cos. That's equal to 1. They're special versions of the number 1. And then, all of a sudden, once your denominators are the same, the rest of it becomes easy. Okay? But you're going to call me over. You're going to say, I got both fractions the same. I'm stuck. And I'm going to say, well, what strategy do you use when you're stuck? And you can either remember build the other side or multiply by the conjugate. So when do we notice that this strategy of build the other side is going to work? When are the key places? Well, if you look diagonally here, do you see the conjugates? And if you look diagonally here, do you see that you would get sine squared? And it matches up with, it'll always match up with one of these. Okay, I can always make a difference of squares with all 3 of those. For the first one, I can either have 1 minus cos squared or 1 minus sine squared. For the second one, can you see that you could get secant squared minus 1? And the third one, you could get cosecant squared minus 1, which are differences of squares, which when they factor have conjugates. So that's sort of a way to recognize them. Now, you're not allowed to multiply across the equation, but you are allowed to multiply by 1. And so this is the build the other side strategy. And it works even when conjugates aren't there. Sometimes you just have 2 sides that you're like, I want to make them the same, so I'm going to make my denominators the same. Our second proof on this one. Okay. Looks like I'm going to change things to sine and cos. The reason this question is here is because the right-hand side provides a dilemma for people. They're like, what do I do with that 2? Should this be this or this? Should I change this to 1 over 2 sine squared theta, or should I keep it as 2 over sine squared theta? Ask yourself what you would do. You have to change it to one of those 2 things. Cosecant squared is 1 over sine squared. So would I change it to 1 over 2 sine squared theta, or would I change it to 2 over sine squared theta? Okay? So I'll talk about that in a second. On the left-hand side, I'm going to get a single fraction. Anytime you have more than one fraction, usually that strategy of getting a single fraction is important. What's my common denominator? I'm going to have to multiply this one by 1 plus cos theta, and 1 plus cos theta, and this one by 1 minus cos theta, and 1 minus cos theta. The bottom is a difference of squares. Comes up so often. 1 plus cos theta times 1 minus cos theta will be 1 minus cos squared theta. Then on the top, when I'm adding, I'm going to have 1 plus cos theta plus 1 minus cos theta. And now I've got a single fraction. I'm going to add things together. But now I'm going to move back to the right-hand side, and I'm going to show a little bit more work to show you why this one is wrong and this one is right. You're like, some of you are like, oh, I picked the wrong one, and other ones are like, yeah, I got the right one. Okay? Well, I'm going to put the 2, I'm going to keep it there and just change cosecant squared. Cosecant squared is 1 over sine squared. If I show that extra step, what does that 2 out in front mean? Well, if I'm multiplying by fractions, I can make that 2 out in front 2 over 1. How do you multiply fractions? So you multiply the numerators, multiply the denominators. So the 2 stays on the top. Over back on the left-hand side, can you see the bottom? 1 minus cos squared. I can change that to sine squared. And on the top, I'm going to get 1 plus 1. 2. Cos theta minus cos theta. Nothing. Oh. We're done. And this one, did it use any new strategies? We only needed strategy number 1. We only needed that get to sine and cos and get a single fraction. I guess we did need to change this 1 minus cos squared to sine squared using an identity. Okay. So I'll give you a question for this one. 12a.